Hi folks, welcome to Lecture 4 on the Second Industrial Revolution during the late 19th century. In order to understand what the Second Industrial Revolution was about, though, we need to go back in time a little bit. We need to recover some ground that you should have covered in the first half of your U.S. history course. In order to understand what something is changing to, we need to understand what it's changing from. So we'll discuss very briefly the first industrial revolution in the United States. Let's get some basic parameters set. We're talking about the time period roughly from the Revolutionary era in the 1770s through about the 1820s and 1830s. The region in which we see this first industrial revolution develop will be the New England states, so think the far northeastern states. Why here? Well, because there's a fairly dense network of riverways in this section of the country. Plus, that's just where some of the earliest settlers decided to set up shop. Much of the machinery that we're going to see associated with the industrial revolutions will begin as water-powered machinery. So in this area of New England, you have a dense network of rivers and waterways which can pull from what we call today hydroelectric power sources. So what's going on with all this new machinery? Well, again, we need to back up before we can go forward. People have always made things. Okay, so industry has existed as long as human beings have existed. People have always crafted tools. They've then used these tools to make other items for their personal consumption or for the benefit of their communities. During this early phase of our nation's history, though, during the first industrial revolution, people largely produced things within their homes or within their cottages. So one way in which we can understand the pre-industrial revolutionary era was the era of cottage industry, or the so-called putting out system. The putting out system refers to a business owner who will put out the work of creating shoes, or he will put out the work of creating curtains, or whatever it is that he wants to sell ultimately to the consumer. He will put out that work to people in their homes for them to complete there in that environment. It's instructive for us to understand how people were paid under this putting out system or cottage industry. You got paid per piece. You got paid for whatever item and however many of them you produced. Say, for example, you are working for someone who produces curtains to put in people's homes. And each week, your boss comes by and drops off the raw materials, the cloth, and in that week, you agree to sew 10 curtains. He will come back at the end of that week and you will get paid for producing 10 curtains. If you got really ambitious during that week, you had some extra time on your hands and you decided to sew 15 curtains, then you would be paid for 15 curtains. What's important to understand about getting paid per piece is that you control your wage in this case. You're not getting paid by the hour because you decide when you work. All the work takes place within your home. So if you decide to work really hard every morning and then take every afternoon off and still meet your goal of what you want to get paid, more power to you. This will change radically, however, once we start to see machines taking the place of human labor. When companies begin to invest in some of the newest technology to speed up the production of certain items, when machines start to take over what had been done by hand, this fundamentally changes everything about how people work, where they work, and also how they get paid. When we talk about the first industrial revolution, now we are moving the production of goods from people's homes or cottages to factories. Now the work doesn't come to you in your home. You leave your home and you go to a factory in which the production of that item is all taken care of by these machines, and human beings are there to monitor the machines. For this reason, because a machine can often perform a task much faster than a person can by hand, you don't get paid any longer according to your output because you're not the one creating those curtains or spinning that yarn. Now you get paid by an hourly wage. This is what's meant by the introduction of wage labor. Now it is how much time you are spending at the factory monitoring those machines, refilling them. So this fundamentally changes not only where people work and how they get paid, but who is in control. In the time of cottage industry or the putting out system, you were in control of when you worked. Now that is no longer the case. Now you have a manager walking the floor of the factory, making sure that you're refilling spools or that you're greasing the equipment so that it can continue functioning. So this represents a loss of autonomy on the part of many workers with this shift from in-home labor to industrial labor at factories. As for the products that are being produced during the first Industrial Revolution, it's largely cloth, it's largely clothing, it is largely textiles, shoes. It is things that people used to produce by hand at home, but now machines are simply speeding up that process. Now let's move on to the second Industrial Revolution so that we can do a little bit of comparing and contrasting between the two. Right off the bat, we're talking about a much later time period chronologically than the first Industrial Revolution. The second Industrial Revolution really sort of reaches its heyday from around the era of the Civil War up through the early 20th century. We're also seeing a slight geographic change. For centers of manufacturing during the second Industrial Revolution, we're moving away exclusively from the Northeast. We're moving a little further to the west. This is mirroring settlement patterns in our nation's history, that as our nation's population grows, that people are steadily moving westward away from coastal areas into the upper Great Lakes region or the upper Midwest region. A similarity between the first and second Industrial Revolution is that we are still talking about machines taking over what people had done by hand. Certainly when we talk about the continued production of consumer goods, people still need shoes during this period. They still need clothing and fabric and what have you. So we will see continued growth in those industries, the textile industry, during the second Industrial Revolution. Here, however, is where things are a little bit different. During the second Industrial Revolution, we will start to see the new production of heavy equipment in some of these factories. We're going to start to see the production of capital goods equipment in these new factories. What do I mean by heavy equipment? Let's think about mechanical reapers and harvesters. Massive pieces of equipment that take many different workers working in specialized tasks just to get it out the door and for sale to American farmers. Capital goods equipment is equipment that's going to be used by other businesses. Capital goods equipment would be something like a locomotive engine. An individual American citizen is not going to be going out buying locomotive engines for their personal use. Railroad industries will be purchasing locomotive engines. All right, so you're selling to another business so that that business can then go out and make money. Another big difference with some of these large-scale production items is that you're going to have to recruit an increasingly more sophisticated and well-educated workforce to produce some of these items. For example, you're seeing the chemical industry in the United States developing during the late 19th century. And in this case, if you are blending certain chemicals for manufacturing use, you need to make sure that you're not mixing chemicals that are going to explode. So you're going to hire, university-trained chemists to be behind the production of some of these goods. Or you will be hiring mechanical engineers to design better engines for these locomotives. But let's be clear. We will still need unskilled or low-skilled laborers to produce many of these items, especially in large quantities, or to tend to some of this new, larger-scale, sophisticated machinery in these factories. Ultimately, it boils down to this. During the second Industrial Revolution, we now have factories that are much bigger in scale. They're producing products that are much bigger and much more sophisticated than anyone could have ever produced in their home by hand. And a lot of the newest developments in machinery during the second industrial revolution will also be water powered, but they will increasingly be steam powered. More and more, we're seeing it's steam engines that will be powering some of these huge pieces of machinery rather than the old school water wheels. The second industrial revolution was also characterized by the development of many new materials for industrial purposes, for building purposes. Steel is a very good example of this evolution in material sciences during the late 19th century. By the 1850s, Englishman Henry Bessemer developed a way to make steel from iron, with the result that steel was a much more durable product than iron. By baking out the impurities, you could result in a product that could withstand much more stress, much more repeated stress over time. Strangely enough, steel also over time became a cheaper material to produce than iron, so it became beloved among many builders of the day. Steel was also slightly more flexible than iron. This may not sound like a good thing, but it is. If you're talking about railroad ties that have these multi-ton locomotive engines and the cars that they're pulling going across them multiple times a day, then you actually need the component building material to give just a little bit under these enormous stresses. Iron railroad ties would get brittle over time. They would develop small stress fractures and eventually split, and it would bring railroad traffic to a standstill in the time that it would then take to replace those broken iron railroad bars. That's not the case with steel. Steel also can take a lot of vertical stress, so we begin to see some of the first so-called skyscrapers being built during this period. The home insurance building in Chicago was the first of these multi-tiered structures that will start to change the skylines of many of our most favorite cities today. So to recap, steel is a stronger material than iron. It will end up being more flexible than iron, which is a useful property for it to have. And it will also be cheaper to produce. All this will lead to it becoming widely used for many of the new structures that are going up during the late 19th century or the Gilded Age. Other crucial inventions during the second industrial revolution included the internal combustion engine. This will ultimately lead to some of the first automobiles. We have the telephone. Now people are able to actually hear the voices of their far-flung relatives over this new device. Cameras to capture people's lives, to capture a moment in time. We'll see radios being developed as well by the turn of the 20th century. Other less exciting developments, we'll see the development of the first machine gun in 1885. We will also see other military technologies continue to develop and become much more deadly over time. Let's take a few minutes to look at some important American inventors during this period. Thomas Edison was certainly among the most prolific inventors and thinkers of the age. During his lifetime, he held more than 1,000 patents for various devices that he helped to innovate. He's probably most well known, though, for developing the first commercially useful light bulb. He did not create the light bulb. This is a common misunderstanding. Light bulbs already existed, but you got very few hours worth of life out of them before the filament burned out and went dark. Edison experimented with various types of filaments, essentially settling on a carbon fiber filament, and this extended greatly the life expectancy of a light bulb. Now people are willing to spend the money for this form of artificial illumination indoors. He will also be involved in many different other areas of innovation, including the kinetoscope, which will be an early movie camera. We'll talk more about American inventions and the Gilded Age in the second part of this lecture.